Hello guys, welcome to my channel. So in this tutorial I am going to teach you three methods to find out if a number is prime or not in Python. Okay, let's try the very obvious method where we'll try to divide the number by every other integer less than that number. Okay, and see if it is divisible, then we'll call it a not a prime number. If it is not divisible, we'll call it a prime number. Okay, let's take some random number. Let's define a function first. Just underscore prime and number. So what should be the first condition? The first condition should be all prime numbers are greater than 1. Okay, so 1 is not a prime number. And if n is greater than 1, then only we'll work on that. Otherwise, we don't. Okay, so if n is greater than 1, here we'll do some processing. Let's keep pass here. Else, we will print 1 is not a prime number. Okay, so now we are left with this block where we are going to feed our logic. Okay, so what was the basic logic? Try to divide that number by every other integer lesser than that number. Okay, for I in range of n. Okay, see whether it is divisible by that number or not. Also we have to make sure that we're not starting from 0, so we'll start from 2. If n modulus division by I is equals to 0, what print, I'll use f strings here, not a prime number. I'm not sure whether f string will work in this or not. Okay, here we'll break. Why we'll break? We'll break because we do not want to test further. As soon as we find that number is divisible by any number, we'll break the loop. We do not need that loop. Okay, let's keep a variable as well. If prime, assign it a value false. Okay, let's assign it true. Sorry. And if we find it to be divisible, let's assign that value false. Else, simply continue the execution. So once our for loop is done, we are still inside the if else condition. What we'll do, if prime number is prime. Okay, so our code is ready now. So what we are doing, we are trying. I already told you the logic. Let's try to run that. Let's try to run it with a non-prime number. Let's call it with 4. You can see it is printing number is not a prime number. Let's call it by 6. Again, let's call it by 11, which is a prime number. Okay, so this code is totally working. Okay, but it has one problem. If the n if the value of n is too high in lakhs, it will take a lot of time to execute. Hence, this is not the recommended approach. Okay, let's break it down to a faster code. So instead of now testing it to n, okay, instead of iterating, testing whether it is divisible by all integers less than n, we can still test it with the until the n by 2. Okay, so this is the trick for getting the prime numbers. If the number is divisible from 2 to n by 2, whether n is the number, then it is not a prime number. Okay, let's apply the same logic here. We'll copy the code. Let's uncomment it. Okay, and let's now iterate only until n by 2. Cool. So with just basic modification, what we're trying to test here, whether the number is divisible from 2 to n by 2. If it is divisible, it is not a prime number. Let's test that with a prime number. Here you go. The number is prime number. So our assertion is true. Let's try it with a non-prime number. So as you can see, this code is 2 times faster than the previous code. But still there is a problem. This is only reducing the programming capacity to half of the previous, but that is still a problem because if the number is very big, like in terabytes, and it will take a lot of time to process. Let's comment this. We have the third approach, which is way faster approach. So this is a smarter approach. Now let's come to the fastest approach. So here, instead of checking from the 2 to n by 2, we'll check only from 2 to square root of n. I'll tell you how. Okay, so the basic of this approach is that all prime numbers over 3 are in form of n plus minus 1. Okay, so it will be divisible of 6 plus minus 1. Okay, so we'll test this logic. Okay, so instead of checking every number, we'll only try to check it with we'll try to find out whether that number is divisible either by 2 or 3. If that is divisible by either by 2 or 3, that is not a prime number. Okay, let's define the same code. I'll copy it. Let's undo that. We have to use an elif condition here, and it's less than equal to 3. Let's take out this block. So what if n is less than or equal to 1? So 1 is not a prime number, right? Not a prime number. Now again check for the cases where n is less than or equal to 3. N is a prime number because 2 and 3 is a prime number. 2 or 3 are prime numbers, okay? Let's come back to the else clause, which is our primary logic. I am adding one more check for middle 5 numbers, okay? N is not a prime number. Then I'll come to the else clause. So I have skipped the writing part here for you because the video was getting long. So what we are doing, like previous condition, if n is less than equal to 1, 1 is not a prime number, so we will that number is not a prime number. Okay. If n is less than equal to 3, so but because of the previous condition check, the n must be 2 or 3, so n is a prime number. now for middle five numbers we're checking whether n is divisible by 2 or 3 or not. So this is for 4. Okay, and then we'll move on to our base logic, where we'll try to see if the number is divisible, if the number is a divisible of if the number is a form of 6i plus 1 or 6i minus 1, and whether that is divisible by 2 or not, 2 or 3 or not. Okay, so let's try to see that. Let's run this code. Here you can see the 11 is coming as prime. Try with another prime number. 13 is coming as prime. Let's try with 12. 7 is not a prime number. Let's give it a really big number. See how quickly it gave the output. If we'll test the same code with the previous logic, it will take a lot of time to execute. Thank you guys. This is the first way. Do like and subscribe this video.